Alright guys, in this video we're going to be taking a look at some of the graphs of our exponential functions and just trying to determine, based on the equation for the function, is it exponential growth or is it exponential decay? So to start off, let's just think about our exponential functions in this standard form of a times b to the x. And we want to just start off, let's list some of our restrictions on a. What values can a not be equal to? Well, in this case, there's really only going to be one restriction on a, and that is going to be that a cannot be equal to 0. And let's just think about what's the reasoning for that. If we had f of x was equal to 0 times b to the x, well, we're just going to get 0 times anything is 0. This winds up being just a flat line along the x-axis. There's not going to be any sort of exponential growth there. So our a value, our initial value, cannot be equal to 0. All right, great. So now moving on, let's think about some of our restrictions for b. Our first one is going to be that b cannot be a negative number. So b has to be greater than 0. So b cannot be equal to 0 or be a negative number. Again, let's think about why that is. Let's say I had f of x was equal to negative 2 to the x. And let's just think about trying to graph this. Negative 2 to the first power is going to be negative 2. Then negative 2 squared is going to be positive 4. Then negative 2 cubed is 8. And we're going to have some undefined numbers in there as well, right? If we tried to do negative 2 to the 3 halves, well, that's negative 2 cubed, which gives us negative 8. And then take the square root of that. Well, we can't have the square root of negative 8. All right, so b cannot be a negative number. It also can't be equal to 0. If we have f of x equals 0 to the x, well, what's 0 to the first power? What's 0 squared? Okay, again, that's not going to be any sort of exponential number or exponential growth or decay. And the other restriction on b is that b cannot be equal to 1. The reason for that is, well, again, let's just think about it. If I had f of x was equal to 1 to the x, what's 1 to the first? What's 1 squared? What's 1 cubed? They're all just equal to 1. That, again, is just going to be a flat line. So for b, we know b needs to be a positive number, and we also know that it cannot be equal to 1. So now the question might be, well, how do we tell if a function is growth or decay? If we look at this standard form again, does my a value really matter in this case? No, right? That's just my initial value. It doesn't matter what my a value is equal to. Really what matters is my b value. We've talked about how this is our growth factor before. We could think of it as a growth or decay factor. That's the number that we're multiplying by each time to then get to the next number. So, oh, I'm multiplying by 2, I'm multiplying by 3. Well, then it's increasing if you're multiplying by a number greater than 1. So if b is greater than 1, it's exponential growth. Well, what about decay? Let's think about, what if we're multiplying by a fraction like 1/2? If I multiply by 1/2, I would go from, let's say, for example, I started with an a value of 16. Go 16, then 8, then 4, then 2. In that situation, I can clearly see my y values are decreasing as my x values increase. So if b is less than 1, of course we know it still has to be greater than 0, but it's less than 1, this is going to be our exponential decay. All right, so if b falls between 0 and 1, it's exponential decay. So let's just do a couple of example problems. Is the following growth or decay? So is this exponential growth or decay? Looking at this first one, I have 3 to the negative x. Don't just get caught up in looking at, oh, look, I have 3 to the negative x. 3 is greater than 1. It's growth. It's 3 to the negative x. We could rewrite that as 3 to the negative 1 to the x. Well, what is that the same thing as? That's the same thing as 1/3 to the x. So now, as my x values increase, my y value is going to be decreasing. So this red one over here is going to be decay. And for the blue, I have f of x is equal to e to the x. Well, remember that e is approximately 2.7. All right, well, is 2.7 greater than 1? Yes, it is. And that's e to the positive x, which means this here is growth. All right, great. So now we want to sketch the following. The first one, we already said earlier that this was decay because we know we could write 3 to the negative x as 1/3 to the positive x. So that's decay. Well, let's just think about what's going on here. My initial value is just 1, then it's going down to 1/3, then 1/9, and decay is going to look something like this. Okay, if you wanted to plot some extra values, like I know I have 0, 1, I know I have 1, 1/3. What other values could we get on the left side of the y-axis? Well, what would happen if I plugged in -2? 1/3 to the -2 is the same thing as 3 squared. So I would have the point -2, 9. All right, so that would be my graph of 3 to the negative x. Now, what about my graph of f of x equals -3 to the x? Well, what exactly is going on here? Didn't we say b can't be a negative number? It's not, okay? It's not a negative number because this here was not in parentheses. This is the same thing as -1 times 3 to the x. So now this is exponential growth. However, we're going to find ourselves below the x-axis. So think of taking exponential growth, and we know exponential growth looks like this. Well, what does that -1 do? Think of our transformations. Oh, that -1 reflects it over the x-axis. And so that's going to bring us down. Well, we've got 0, -1. We've got 1, -3. So I'm reflecting over the x-axis. That is going to be my graph of -3 to the x. -1 times 3 to the x. Let's do 2 more here. I've got -3 to the negative x. So let's just try to rewrite this. Remember, that's -1 out in front. And then 3 to the negative x. Well, that's 3 to the -1 to the x. And 3 to the -1 I know is the same thing as 1/3 to the x. So now this is just going to be exponential decay flipped over the x-axis. So this is what exponential decay normally looks like. If I flip that over the x-axis, it's going to look along those lines. And our last problem here, I have h of x equals 1/3 to the negative x. Well, that's 1/3 to the -1. Then to the x, right? I can put double parentheses around it. 1/3 to the -1 is the same thing as 3 to the +1. So 3 to the x. Well, 3 to the x I know is just basic exponential growth, where my initial value is 1 and then my growth factor is 3. All right, hope this helped you guys out. Best of luck as you get going on the homework.